Welcome to Mind Bending Monday. I am so excited that you're joining us today. And I am really excited because today we are starting a new series, Algebraic Reasoning, Critical Thinking, and Number Sense. Do you love a good puzzle? Most people do. And today and in the next couple of episodes, we are going to explore puzzles that require critical thinking, but also help students develop and strengthen their understanding of algebraic concepts. So what could be better? They're fun, they're engaging, and they're great for algebraic reasoning. So, are you ready? Let's get started. Algebraic Reasoning, Critical Thinking, and Number Sense. Episode 1, Balance Puzzles or Mobile Puzzles. If you apply NCTM standards of mathematical practice and NCTM process standards, you are teaching your students to think critically. There is a lot of research to show how important critical thinking is, not just in mathematics, but in all areas of life. So I am very excited about this series. In the next few Mind Bending Mondays, we are going to discuss types of puzzles that require critical thinking, promote number sense, and develop algebraic reasoning skills. Today's puzzles do all of those things. I love these puzzles. However, in order for them to be effective, students must apply strategies rather than using guess and check. So today we're going to talk about how you can help your students really develop those strategies. And critical thinking will be a big part of solving these puzzles. The following puzzle is one that I originally created for a presentation, and these are not always easy to find, but I do have some sources for you at the end. So, are you ready? Let's get started. Here are the basic rules for these puzzles. All weights have a positive whole number value. Each shape has a consistent, unique weight within each puzzle. The right and left side of each horizontal beam must balance, and the size of the shapes or the length of the vertical rods do not affect the value of the shapes. So these puzzles do not follow the rules of physics. You may find some puzzles where physics does apply, but it does not apply to the puzzle today or to the sources that I'm going to share with you at the end. All right, are you ready? Let's get started. Here is our first sample puzzle. The first thing you want to do is, after you've discussed the rules with students, is ask them to make observations about what they think could apply for the weights of each shape. And just give them think time. So they might make a few different observations, and I suggest that you question to make sure they're accurate and then write them down. They might say some things such as, okay, the total is 69, so that has to be here, and all these added together are going to equal that. Okay, but what about the value of each individual shape? Well, they might make some observations such as the weight of this circle and this star is equal to the weight of the oval. Okay, good observation. That's true. What else do you see? And they might say something such as these two circles are the same weight as the triangle. Great observation. That's also true. But eventually they're going to realize that none of those observations give them an exact amount. And there's no guessing and checking. So you really have to come up with some strategies. What shape is going to be really important? Well, they might decide the hexagon is going to be pretty important. Well, what do you know about the hexagon? Well, Some of them might come up with, and I have had students say, well, the hexagon, if you divide 69 by 4, because there are 4 places, the hexagon is also here. And so really, it has to be less than 1/4 of this. So I know that the hexagon is less than or equal to 17 1/4. Okay, that's true. But still, those are a lot of options. So I'm going to have to come up with something else I know. And they're going to really probably be a little stuck if this is their first puzzle. So here are some things that I have done in the past to help them through that and to question them. So with this type of puzzle, we'll have to think, well, let's think. What do you know? You know that you have a total amount, that when you subtract this, it doesn't affect the weight of the sides because it's right in the center. And then I'm going to have to divide. So what else do you know about this hexagon? When you subtract it from 69, you get a number that can be divided by 2. So hopefully someone will come up with the fact that it has to be odd. Okay, well, that narrows down your choices, but you still have a lot. So what else do you know? So what I typically do is eventually get to the point where I say, what do you know about the value of this side? What do you know about the value of that side? Well, I know that whatever it is can be divided by 2. And then I know that whatever answer I have, that quotient can be divided by 2 again. And I know that whatever that quotient is can be divided by 2 again. Now, this is where things are different if you teach elementary versus middle. Hopefully, middle school students will automatically know what that means. For elementary school students, I say, well, for what numbers is that possible? And my students actually just brainstorm and come up with some, and they'll list them, and sometimes not always in order, which I don't quite understand, but that's okay because it's their thinking. So we'll just write it down, and eventually they'll come up with 8, 16, 24. And as they come up with numbers, you can write them all down and say, what do they have in common? Well, this is where you can have a little mini lesson. Those are all multiples of 8. And why is that true? Because if you have a number divided by 2, divided by 2, divided by 2, and it equaled 1, you would say times 2 times 2 times 2 to get 8. But if it's 2, it's times 2 times 2 times 2. But you're always multiplying 2 times 2 times 2, which is 8. So then you know those are all going to be multiples of 8. And that becomes very important. So if I can determine the value of the star or the value of this side, what shape can I also definitely determine? And have students experiment with that a little bit, and they'll come up with, okay, those, but that's all on this side. So what shape can I determine that will affect the entire puzzle? And or have students make a list of all of them, and then which one is going to be most helpful. And hopefully students will see that if you know this side, you also know this side, which means you also then know the value of this hexagon. And that is really going to be helpful. So to determine that, I'm going to make a list because it's not very many values. I know that this has to be less than half of 69, and I know it has to be a multiple of 8. So I can make a list. There are 4 possible values for this side. And if this side right here is 8, then this side would also be 8, which would mean I know this hexagon would be 53. So that's how you determine those. And you can do that for each one. And as you write that down and figure it out, you come up with this chart. But we're still not guessing and checking. So we can't try all of those, but we can use these with what we already know. Well, what else do we already know? We know that the hexagon is odd. Not so helpful because all of these are odd, but that's not true in every puzzle. So you do want to bring up the fact that you should test against everything you know. But some students may have also decided, and if they haven't seen this before, they'll see it now. Could this possibly be 53? Because that would mean this whole side is 53, which would mean this whole side is 53 or greater than 53 actually. So that's not going to work. And so if they haven't figured that out before, when you put real values to it, it will work. And even if you look at 21, well, if this is greater than 21, or just say it's 22, what is 22 plus 22 plus 22 plus 22? And they'll know that's too much. So then, using no guess and check, they can determine that those must be the values. So now I can start to say, okay, I know that these sides are both 32 and this value is 5. And I know this value is 5. So if this is 32, what is each side? Each side would be 16. And each side here would be 16. Now, here I'm stuck. I know that together they have a weight of 11, but I don't know the weight yet. And here I'm stuck because this rectangle has to be subtracted before I can divide by 2. So I'm not sure what that is yet. I just know it's less than 16. So I'm going to keep going. But I do know this, 8 and 8. And so now I know this triangle is 8 and the circles are 4. And because they're a unique but consistent weight, I know this is 4. And I know that this is 8. So if these two have a combined total of 13, I know this has to be 3. And so this has to be 3 because it's consistent. So this side is 7. And if this side is 7, I know this oval is 7. Now, this 7 plus 7 is 14, but the weight of this entire side is 16. So this yellow rectangle must be 2. And if I know this is 2, I know this is 14. And I have solved my puzzle. And I did not use any guess and check. I used critical thinking and I used number sense. No guess and check. And it does develop algebraic reasoning. You've got the balance. So these puzzles are great. I hope you like it. So let's talk now about where you can find them. These puzzles are amazing, but they are not always easy to find. I have included my absolute favorite source, which is In the Balance. They're called In the Balance Algebra Logic Puzzles, and they're by Lou Kroner. Originally, they were published by Creative Publications, but they were purchased by McGraw-Hill, and then they were discontinued. So why am I even mentioning it if they're out of print? Well, because if you can find a copy, it will be worth your effort. There's a version for grades 4 through 6, and version for grades 7 through 9. I recommend, even for middle school, that you start with 4 through 6 if you can, because a lot of the strategies that students will learn will be applied in more challenging puzzles. So, if you look them up, there are some universities that have copies in their library. So you might live close enough to one of those places that you can go and check it out from the library. You might be able to find a used book. Somebody in your school might have a copy that you could borrow. So it's worth asking, and I wanted to include it. There is an interactive site where students can build puzzles, and I wanted to show it to you because you have a play and a build. And if you go to play, they are pretty basic. So that would be great for younger elementary students. Even if you go to the master level in the very end, they are really not, in my opinion, challenging enough for most middle school students and even some gifted or high ability elementary schools. So you're going to want to find some other sources, although this is a good source to start. But the best thing about this site, I think, is the build. Because if you learn how to build a puzzle, you can build your own. You can save it. I haven't tried this yet, but you can save it and share it with your students. And there are lots of different ways. You can even just copy the web address and they can go straight to it and solve it. So I created right here the puzzle that's exactly like the one we just solved. I just used different shapes. So they're a little more limited on the number of shapes, and you can hide the values, but I think that's a great place if you want to start creating some of your own. I hope you love these puzzles as much as my students and I have loved them. So have fun and try these puzzles this week. Thank you so much for your time. Time is such a precious resource, and I know you are so busy. So we really value your thoughts, and we are giving away a prize every month. So look below and you can see how to submit to win. If you like this series, you definitely want to submit, because the prize this month are puzzles that are related to algebraic reasoning. So we hope you'll join. Thanks again, and don't forget to hit like and subscribe. We don't want you to miss a single episode of Mind Bending Monday. See you next week.